Thanks for the introduction. I'm Marcel and I'm from Manchester. As you can see on this picture, this is the university where I'm working on a beautiful British summer day. And what we do is crowd science. Maybe you are surprised as I was when I heard for the first time that Manchester is the Hollywood of crowd science in the world. And it is actually true. It is a hub for crowd science, and we research, we teach, we try to find everything connected to crowd science, crowds, where they gather, where they move, where they meet, and where there may be potential or risk combined to them. And we have, like being Hollywood for this, we have the chance to work with some of the greatest partners in the world, and together go on this mission to understand those crowds that we gather, understand them more. And I want to take you on this experience with me, and we'll talk a bit about our work in road races and the marathons. And to not be rude, but explain who I am. Yeah, as I said, I'm Marcel. I'm senior lecturer in Manchester at the Metropolitan University on the topic of crowd safety and risk analysis. I studied crowd science and like another master in different universities in Germany as well as in the UK. During this, I spent 12 years in the armed forces, as was widely said. So I didn't have this business background, but pure interest in this. And then during this time, as well as afterwards, I was working with a lot of big projects. We mentioned Liverpool yesterday. There was definitely a great project working with them, as well as transport hubs like airports or undergrounds. And you see some of those examples there. And that's what we do now in Manchester since a couple of years. And we're building this Hollywood atmosphere. Come to Manchester whenever you can, just let me know. And those are some of the pictures of those projects that we work with. And when I say we're working with them, that's really what we do. Of course, there's a consultancy part because we all have the same goal of making those events successful and safe. But it is most of the time dialogue of like how to understand those big events. And if you see on the top left, that is the Expo 2020 in Dubai. A really big event, $45 billion used to have 25 million people who will navigate through this expo in 5.5 months. And no single queue can be longer or shorter than expected. Everything needs to work from day one to the last day because you also can test it. It will be the biggest expo ever, and there's no chance of testing it, but you need to foresee, will everything work absolutely to schedule. On the top right, you see Dubai New Year's Eve. They also have a great challenge, as do most of the New Year's Eve events, because you don't have tickets. You don't know how many people will show up. You pretty much promise your whole city you can come and you can have a look, and then you hope that not more people show up than you have space for. So working with them or working with Sydney or London on those New Year's Eve events, that's a great learning curve, as is the lower left, that's Canada Day, particularly the one in Ottawa for the 150th anniversary of the country. And again, that's one of those things that you can't really test before, because how often do you get the chance to celebrate such a university of a whole country? And on the lower right, that is just one example for those many stadiums that we work with. Because we talked about Anfield yesterday, I took that off and replaced it with Duke Blue Devils, because they have an important game going up. Go Duke. But one thing that's close to my heart, and that's a lot of resources that we use, is for marathons. I mean, if you look at a picture like this, or if you listen to the speakers before me, there's no way not to love it, and all the energy that's in marathons. And also from a crowd science perspective, there's so much in it. In the stadium, you need to get them in on time, and then they sit for 90 minutes, and in the middle they go for a pee and for a new drink. And then they go home again. There's obviously more to this, but in a marathon, they never sit. Like for 9 hours or for more, everybody's on the move, and not just the runners. Even the whole city is going to the course, so nobody sits. And you need to do it as a pop-up event. You can't build your fortress, your stadium, for your purpose. It needs to be on the day built by you, and then you need to keep this overview of sending 40,000, 30,000, 50,000 people in shorts over 26.2 miles. And because I'm a scientist, I'm allowed to show graphs and numbers. in my presentation, and I keep that short though. So what you see here is what a marathon looks like in numbers. Those are the finish results, and they're pretty easy to explain, I hope. From left to right you see the time of the event from 0 hours up to 9 hours, and then you see on this graph where people and when people finish. And I mean, you see this big peak at 4 hours. That's understandable because it's one of those goals, just as 3 hours, 3:30, 5 hours, that people want to reach and that people then have as their finish time. So that's pretty straightforward, but there's actually more to this because our marathons are now three-dimensional. That means not everybody's starting at the same time. This is their journey. What we see here is their journey between start and finish, but we need to get them to the start first. And you saw that in Singapore, and you have experience with this probably, that you have like this long queue behind the start, and everybody would start like 5 minutes, 10 minutes, 30 minutes, or later after the first start shot. So that creates a different curve because not everybody is on the same time. And we call this yellow graph, we call that net time. This is what you will have as a net result on your certificate from start to finish. But technically it's invisible. You will see it on your result. But your actual journey is to the start, 10 minutes maybe, and then 3 hours of a running if you're fast. So after 3 hours, 10 minutes, you will stand in front of the race organizer who will give you your medal. And also your friends need to know it's not 3 hours, but 3 hours 10. So that's why the yellow one is invisible, and the blue one, that's what counts for us. This is when those people on different timings will actually be in front of us. And like we demand their water, demand their medal. To not confuse you too much, I just take the yellow one off, because as I said, it is invisible, and it just makes sense for those runners on their certificate. Operation people need to know this line that you now have on, which if you would describe it, this particular one, it goes up not too steep, then has a plateau for a while, and then goes down again. But it could also look like this, where it's like a bit of a steeper peak and then reaches its peak performance at a desirable time, and then it goes down again just as steep. And if you imagine, you put yourself in the shoes of the volunteers that's hanging around those medals around their head, and there's this point when it goes really, really quick, and your resources are tested, and then you're over it and you try to make it home. So it could look like this, but it could also look like this. Devil's Horns has 2 of those peaks visible, and that's a different curve. And it could be any of those 3. But the secret behind what we see here is all 3 are based on the same net time and totally dependent on how you start. Because if you start all in one go on 100-meter wide road, or if you start them in 3 waves on 50-meter or 10-meter or 5-meter, that will have an impact. And it could be a result in any of those shapes. And I explained to you, and you know how important this shape is. So there's a lot of educated guessing in this, but maybe we can go a step further and really link the start to the finish and to every other point on the course. And I will come back to this. I'll go back to pictures now. So once we said we want to figure out, and we think we have figured out, how the start is connected to the finish, we had a challenge with New York City, and they challenged us and said, if we tell you of the New York City Marathon, how we start our race, we give you the dimensions, we give you the timing, and here's a picture. Can you tell us, as a challenge for you, how many people come across the finish in our busiest 5 minutes at the finish? They didn't give us anything else from the finish. They just gave us all the details we needed to know from the start, and we tried to calculate if we can. And the busiest 5 minutes is 4 hours 25 into the race. Okay, we were up for this challenge and said, we're going to calculate based on your start what we think your finish looks like. And we came up with one of those curves that you saw already, and said this is what it will be like. And to answer your challenge, we looked for those busiest 5 minutes, which you see here. Yes, we calculated right, it is the busiest one, but let's see what we can come up with. And we said, from our calculation, based on your start, it will be 1,366 runners in those 5 minutes. And we left it and were checking for the answer, and for real it was 1,367. So we found out two things, and one of the two is that we are not perfect. But it is something that we can work with, and we reach an accuracy that might be something, we might be onto something here. And remember, this whole curve is calculated, so this is not recorded. This whole thing was developed based on the start. So we said, why not compare it to the whole curve of what happened on the day. There it is. If you can't see the difference, that means we did our job right. Yellow is the recordings, and red is the calculation based on this start. But that means we can also change it and adjust it now that we think we understood the connection. So I want to bring it to a good example of a great marathon that we worked with afterwards, or like for years now. This is a great city of Chicago, and apart from the great skyline, you see Grant Park, which becomes pretty much Marathon Park on Marathon weekend. They have like all the operations in there. It's an amazing city and it's an amazing weekend, and it looks in the operations. Where do I need to point this? I just try my luck. Yes, that's what the start looks like. And you see on the lower end, you see the actual start line, and then you see this long queue that I described before and that you know from the weekend, that you know from your experience of 45,000 runners lining up, waiting for their time to start. So we did the same. We have a great relationship with them. We work together and understand each other. So we did the same, looking at their dimensions, at their timing, and basically calculated again the busiest 5 minutes as well as the whole curve, and had similarly good results. And say, let's now not do it just for the finish, but do it for every single point on the road. So we sent them off, and what is the implication of this for the whole race? And in this graph you see pretty much how those three waves, how they started, how they meld together to one race, and we can check this for every single spot on the race and come up with a slide or a graph for every single point. This, what you see here, is 10 miles into the race. Could be 10.1, could be 13.8, anything. And we can calculate or simulate this graph for everybody and every point that we're interested in, that we want to check. So not just the graph, but also numbers to it. So here, mile 10, as I said, what does the peak mean? It is 431 people per minute. And if you're interested in this point, or if you're running the aid station there, you can check, can I live with this? Can I prepare for this? Thanks for the information. Or should I flag back and say, can you lower this? And we would lower this at the start. When is the actual peak time, and also including this visual graph telling them after the first peak, don't be fooled, there's a second one coming. And we give them the minimum width requirement in meters or in feet. What does the crowd that's arriving at your spot, what do they physically need? And the next, now you can see that we're nerdy scientists. Now we said, like, actually, if we can look at every point, we can also look at every point at every time at the same time. So we came up with this. That might be a step too far, but when working with Chicago, they actually saw something in here, because in every single slide, they see 1 kilometer of the race, stretched over time, stretched over a number of people. But back to the start. Because if that is what we want to reach, if we are happy with every single spot on the course after we simulated this, the last time that we can actually affect the runner without the runner being mad at us is the start. It's the last time they cooperate with us, and then we send them on their journey, and it's up to them how fast they are between start and finish, and we can't or shouldn't interfere with that. So what you see on this picture is just a tiny part of the start operation. You see some dimensions there. You see everybody who's there in a yellow vest, they are part of the operations. And everything on this start is laser measured to pretty much German perfection, so that we were happy. And we knew if we start like this, it should meet our expectations along the course. And Chicago, those people working in Chicago, they are a dream to work with, because everything that we came up with on the table, they put into action to absolute precision, and they show it to you on a time lapse. It's 12 seconds, but it's actually more than 1 hour of tightly scheduled and choreographed precision of getting those different waves on those different corrals perfectly on the road. So, and especially Chicago is an example where you come up with a plan and then they put it into action and you're amazed by the precision that they actually do in the operations. But that enabled us to foresee actually the density for every single spot on the course. Like this is density in Chicago at one particular course, it's just one example on one particular point. But this is what we envisioned and this is what we planned. And with those operations at the start, they enabled us that this is exactly what's happening, as well as on every single aid station. On every single aid station, that we, again, were able to predict how many cups over what time, how many in total, and what does that mean. And it helps us a lot, and it was not just used in density and aid stations, but with so many more examples now that we were able to foresee and to adjust everything from the start. And it was used for, as I showed you, straightforward for road width, for road closure, for staffing, not just staffing in general, but also staffing over time and over space. Like when do I need more people here, and when do I might have too many resources there that I could recycle. Staff and resources as well as expansion. That's a good question. How can we grow without working faster? And that's not just a question in the marathon world. Television, they seem to love it because we were able to tell them our schedule. London Marathon, for example, they start at different locations, and it's interesting for BBC to know they start here, then they start there, and then this is a point of interest, and this is where they come together. So being able to give something like this to them, crossing times of spectators left and right, junctions, merging, as well as emergencies. I mean, it's still operations and not just numbers. It means something could go wrong, voluntarily or involuntarily, and how can we then make the same calculation on the fly and like get us back before the wave to foresee everything and maybe adjust something. So mid-wave changes. And it has, for good reason, has those 3 points there, because that's up to the question of the race organizer. As university and as marathon enthusiasts, we had the aim to make this happen and to find the connection. But we don't have an own race, so now it's this great dialogue that we have with some of those big races to foresee what's of interest to you. If you could look at the whole race at one time and at every single spot, what would you look for? What would you use this for? But it mainly can be put under two headings, which is safety. We use it for the safety of the runners, as well as for the runner experience, to ensure a better runner experience, or despite all the constraints that we have and the growth that we imply, how can we ensure that it transports the runner experience that we want them to have? So I just take you to, now that you know everything that I know, I run you through 2 examples. If this would be your marathon, and those is a real example, and this would be last year, you now understand those curves and see, okay, we have this peak after 4 hours, that is pretty normal, or 4 hours, 10 minutes, and then it goes back down. How can we adjust it? How can we optimize it maybe? And we developed a second curve and said, like, this would be a new option. This is what you could do next year, if that's of interest to you. Just one of those options. And to describe it, we would say, well, there is no peak anymore. We don't see a visible peak anymore. And the general plateau is lower than everything we experienced in the year before. And it might be surprising for you to learn that the red one, the new option, has 10% more runners in it. They're just distributed more evenly. And this would be your option if you decide as a race director to go for it, or that reminds us of those 3 ones that I showed you before. Pretty much every shape is possible, from the steep curve, which is like the fast peak, maybe that's what you want, or the devil's horns, or Mickey Mouse ears, or we can do so much now that we understand it and have the time to simulate it on the desk. And who follows marathons and is familiar in the field knows that a lot happened in Berlin this year. That was just the first runner that finished, but there were lots more behind him. And what we achieved in Berlin this year is by using this technology. Oh, I never said the name. It's called Start Right. You saw that in the corner the whole time. But what we achieved in Berlin this year was that we were able to give back the roads 10 minutes earlier. So the race was basically shortened by 10 minutes from as far as the city knows. And at the same time, we were able to reduce the stress at the finish. Like it was 9% less busy. And 9%, you notice that if you're the metal guy, you feel you go with stronger home on the end of the day. But at the same time, we had 1,500 more runners. So our good friends in Berlin played around with this and like won in all 3 disciplines. Like were faster, had more runners, and like were less stressed out at the finish, just by adjusting what they already had, the resources that they had, adjusting them with a better understanding. That's the actual tool that we use in the background. Don't be fooled. You put in all your dimensions and you put in all your timings and all your runners and so on. But what happens in the background is 6.5 million calculations. We know it's like a big race, and the journey, the individual journey for every single runner changes by every centimeter that you change at the start. And what that means on the big scale is what we found out now with this tool called Start Right. And all of this would not be possible without working with those great partners of World Marathon Majors, and some of them sit here and maybe Tim is watching. But it is the cooperation with those big races that basically really stand for and live everything that Tim yesterday when he sat here was talking about, this sense of sharing, this sense of growing together and helping each other to lift, to not mention boats again. I also want to thank Mike Nishi, especially in Chicago, because he really lives on a daily basis this professionalism, this dedication, but also being open to everything, open to include stuff, but also share with others. If you have a chance, talk to the man or go to his presentation this afternoon at 3:30. And it's great working with them. It's great working with his team because they all understood it. And if you're just as open and dedicated, you will get the chance, but you better not sleep so much and love what you do. Then you're going to be successful. And I want to thank you for listening. I know it's always hard to talk about statistics and science stuff, and everybody is happy to be out of school. But it enabled a lot of great conversations of hey, what can we do? As I mentioned, we don't have an own race. So that opens it up for questions, because we have a couple of more minutes until they throw me off the stage. So yes, please.
Yeah. Crowd estimation happens inside venue. Oh, sorry. Crowd estimation is an AI field as well.
Yeah.
Are you guys working with any vision-based crowd estimation?
So here's the thing. There are 2 answers to this great question. We do it from a science perspective and then find the right technology to put it into the field, but don't go the other way around of using the technology to find a solution. That enables us to always start with a blank piece of paper and then find the right people who help us bringing this into the field. Something that pretty often we see a confusion is following a crowd down the road, tracking them and then estimating what would be the next step on the journey. And all of this is correct and all of this has a justification. But what we can do is do it a year before or 2 years before, so we don't need those first couple of points of reference of they passed point A and point B and now we estimate point C. But we do all of this based on the historical data in this particular city, on this particular course, and every course is 100% different. So what needs to be understood is, one is the calculation based on the precision that we talked about, and the other one is then the documentation, or you follow somebody down the road. But there's a difference if you do it in the control room, and that's something we definitely do, or if you do it a year ahead. It gives you a bit more time to react and adjust. Did that answer your question? I'll be in the speakers' corners afterwards. Any other questions? Yes, please.
I noticed on the aerial shot of the Chicago Marathon start that the start chute had a bit of a bottleneck, about 10 meters in front of the start line, or behind the start line, whichever way you look at it. What was the reason for that? That seems a bit odd.
Great question, great observation. Not 10 meters, but 100 feet and roughly 26, or exactly 26 feet in width. There's a lot that matters, and all of this is put into practice at this great example of Chicago. What matters is the geometry of your start, because there's an impact. It's like the same with a door. If we open both doors to the buffet, we get our coffees faster than if we just open one. Also the timing of it. That's what Berlin found out. If they start in 4 waves instead of 5, it actually is better. So that's how they got their 10 minutes, which is counterintuitive in a way. But also how you order your race. Like how do you order that the fastest runner is actually in the beginning or in the end? And you can't say you need to have a perfect order, but what you can say is you need to know the order. And then you can work on that basis. You might be then able to improve it, but how perfect it is doesn't matter, but you need to definitely know it. And there's all those 3 points, the geometry, the timing, and the order, and also the part of psychology that's included in all of this. It's not just numbers. We don't do just numbers. And that then ends in a graph like this, where you can see, if you now turn it, how from those 3 waves in the beginning, the finish then looks like. And I sat with Mike in New York just before the New York Marathon, and he spotted something just by have a glance over it. He spotted something, and it's like, oh, we need to work on this. This might be something we can improve to make it even more balanced. And the reason is, that might be another answer for the question. The reason is because our races are not 2-dimensional anymore, but 3-dimensional. It takes an hour to get everyone on the road, or longer, or about an hour. And in the good old days, on the top photo, everybody was at the start line. And if you look at regulations by IAAF or USA Track and Field, it still says in the regulations, at a marathon, everybody goes to the start line. Well, you could be a mile away, or you could still be in the bus in New York or anything. That doesn't apply that much anymore, and we need to include those geometry parts, timing parts, and order parts much more than on the top picture. That's a great question. I don't have no books to give out, unfortunately, for that. Any other question? Or I donate my time. We have like 120 seconds left, so I would donate this time to the organizer. It's up to you.
It won't go astray. Any questions for Marcus before we sign off? One here, thank you very much.
Thank you, it's a great presentation, great work. Is there any patterns to be learned in terms of the advices ahead to the race organizers on the course deviations or how people behave in a certain course structures? Yeah. So the race organizers could get the advices ahead, what kind of measures they could take to adjust the course and the turning points, different, especially when they have laps or when people are passing each other, etc.
Yes. So we calculate every single point on the course and look for conflicts. Could be we don't have enough space, or different people are merging from different courses, or separating again. And whenever we come to a point where we see, well, this might be a conflict, we look at it mathematically, like how much width do they need, but also psychologically. That's why we work so closely with those races. So whenever there's a conflict, there might be 2 sides to the solution. Give them more space, but also negotiate it, because they're not just numbers, they're runners. And you can work with them. Obviously, at the start, as last time, you can delay them, and everything from start to finish is up to them, and it should be up to them. But of course, you can inform them, just as you could on a 400-meter track. Everybody knows on the straight you can pass, and then you try to find your order in the corner, and then get yourself ready to overtake. Does it sound too competitive? But you can work with them on this basis, like in London, for example, where they have this big ship and the hairpin. Everybody knows about it, and everybody prepares for this, and nobody is surprised. But you need to get them on the mission, definitely. Cool, now I'm running out of time.
Ladies and gentlemen, can you join with me in thanking the science of crowd control? Marcel Altenburg, thank you so much, Marcus. Well done.